Hello, my name is Beyza Yaman. I'm a postdoctoral fellow in Adab Center along with Dublin City University in Ireland. In this video, I will present to you my work named as Quality Metrics to measure the standard conformance of geospatial link data. Think about self-piloted vehicle, which is using a machine learning model. Quality of the dataset is critical for the performance of the model, which has an immense importance in the domain of self-piloted vehicles. Geospatial data suffers from high demands on quality in real life. Besides the self-piloted vehicles, lack of quality data causes major problems, such as 2017 Irish Coast Guard helicopter crash due to navigational problems. However, it is not always trivial to generate high-quality data because data production cycle has a dynamic structure, and the problem in the cycle may cause an iterative error along the data pipeline. In this project, I'm collaborating with Ordnance Survey Ireland, which is the national mapping agency producing geospatial data. This paper is a part of my project called Link Data Operations Based on a Quality Cycle, which is abbreviated as Link Data Ops. Within the scope of this project, we propose to implement a tool which responds to dynamic requirements of data quality processing cycle, which assess the quality of data and the mappings via standard conformance metrics, and find the root causes where the problems are occurring and improve data continuously for an end-to-end data pipeline. The research question we ask in this paper is, to what extent can quality metrics derived from geospatial data standards be used to assess the standard conformance and quality of geospatial link data? In order to achieve this, the data quality standards were investigated in two main groups: geospatial datasets and metadata for traditional data, included in the ISO 19 series, and geospatial link data, which are published in the OGC's Geosparkle document, and W3C best practices for spatial data and web of data recommendations, including data, metadata, and schema definitions. In consultation with OSI, the most essential conformance metrics were identified. These metrics enable the assessment of a dataset in terms of standard conformance, including metadata, spatial reference system, and geometric classes. The rate of each metric was computed on the whole dataset to give values in the range of 0 and 1, as is the best practice for quality metrics. In this paper, you could see three preliminary metrics that we implemented for geospatial data. And one is the geometry extension object consistency check. And this, according to OGC Geosparkle requirements, geometry types should be represented with WKT and GML serialization, regulated with ISO spatial schemas. Thus, in this matrix, if the entity in the dataset is a member of geometry class, then this metric checks the rate of employed GEO as WKT or GEO as GML properties in the dataset. On the other hand, second metric is links to spatial things check. W3C suggests using an appropriate relation types to link spatial things, which is any object with spatial extent, such as people or places. This metric detects the rate of entities having links to external spatial things in other datasets and internal spatial links within the dataset. On the other hand, the third metric is consistent polygon and multi-polygon usage check. Polygons are topologically closed structures, thus the starting point and the end point of a polygon should be equal to provide a consistent geometric shape. This metric checks the equality of starting and end points of polygons to see if the loops are closed. In this study, we investigated 4 open datasets. Preliminary results show that OSI has the highest rate of conformance to the metrics, followed by Link Geodata and Ordnance Survey UK. Greek Geospatial Link Data has the lowest rate of conformance to the metrics. You can find more detailed info on the results in the paper. As a conclusion, we have already implemented a governance dashboard built upon the LUZU framework. The dashboard allows users to visualize quality metric observations and analyze quality scores in a data production pipeline. The results showed us that geospatial link data is still a little bit behind to conform to the standards, but it is fruitful to use standard conformance points as a basis for new quality metrics. Thank you for your attention.